Hello ladies and gentlemen. My name is Sabine Gehlmeier and I'm Business Development Manager at the Fraunhofer Institute for Building Physics IBP. Today we will have a deeper look into different options to determine thermal comfort. We will then focus on one specific evaluation method that is very well established, the predicted mean vote, according to Fanger. Finally, we will again look at our lighthouse project in INDORE. Together, we will determine how the residents there are likely to assess the indoor climate. Let us start. There are different models that are used to determine thermal comfort. These models differ strongly in terms of complexity and accuracy, and research is still underway to determine which model can best represent processes in the body. Here you can see an overview of different assessment methods, whose complexity increases significantly from the left to the right. The main difference lays in the level of consideration. The Fanger model on the far left, for example, allows a simple calculation of thermal comfort based on room climate conditions. The further to the right we go in this overview, the more detailed the body functions are included in the assessment. This rational approach is used to describe the reaction of the human body to a thermal environment. What all models have in common is that the ability of thermal adaptation is not considered. Usually people perceive larger temperature fields as comfortable than calculations suggest. Current research shows that especially people in India are very adaptable to different climates. Most of the time, consideration according to the simplest model, the Fanger models, are often sufficient because they indicate tendencies. If the indoor climate is of high relevance, for example for sick people, a more detailed consideration is necessary. In most cases, however, the Fanger model is used for simple evaluations, and so we will focus on it now. The Fanger model is used to derive an index for predicted thermal sensation for the combination of different variables. The prediction of thermal sensation is influenced by metabolic rate, clothing, insolation, air temperature, air velocity, mean radiant temperature, and relative humidity. The quantification of the thermal sensation is done with the help of a 7-step scale, which represents the expected average rating of the indoor climate. The PMV can predict how the average evaluation of the thermal indoor climate will be made by a larger number of people. The PMV is used to determine the percentage of people who are potentially dissatisfied with the indoor environment. It's called the predicted percentage of dissatisfied, PPD. The Fanger model assumes that 5% of the people are always dissatisfied with the indoor climate. So if we now know all conditions like metabolic rate, clothing insulation, air temperature, air velocity, mean radiant temperature, and relative humidity, we can then calculate the PMV, the predicted mean vote. If, for example, we calculate a PMV of 1, we can guess that around 25% of the people will be dissatisfied with the climate. Let us now move on to our lighthouse project in INDORE and apply the Fanger method to the anticipated indoor climate in the constructed buildings there. Here you can see the climate of INDORE. INDORE is located in central India. The climate zone there is defined as tropical wet and dry. The climate is warm to hot, but because of its high elevation and inland location, even during the hottest month, the nights are relatively cool. Rain falls almost exclusively in the summer monsoon month. Relative humidity varies through the year, being lowest in April at about 20% and rising to as high as 85% in August. In the following, the thermal comfort is determined with the help of the model according to Fanger. For each day of a whole year, we have calculated an average value for the PMV and the PBD, and we plotted in this diagram. 1 point corresponds to 1 day. Normally, we accept that not all people are comfortable with the climate. In fact, we assume that 5% of people will always be uncomfortable no matter what. Generally, we are also willing to accept if 10 to 20% of the residents feel uncomfortable, especially in the sector of affordable housing. However, when the dissatisfaction exceeds to over 20% with a PMV greater than 1, we usually see a need for action to improve the climate. Here we see that we can still accept the dissatisfaction due to the cold. We don't necessarily have to do anything here, since the residents still have the option of dressing warmer, for example. The situation is different when temperatures are too warm. We see that on many days of the year, up to 100% of the residents will find the climate far too hot. So then, there is an urgent need for action here. In contrast to the bioclimatic comfort diagram we learned about in Module 3.5, this diagram does not give us any direct hints as to what measures can be taken to improve the climate. But in previous modules, we have already learned that shading the windows, for example, with exterior blinds can significantly reduce overheating. In addition, a ceiling fan usually also brings an improvement due to the higher airspeed. Whether these measures are already sufficient to shift the climate into an acceptable range cannot be predicted without further analysis. And with this, I say goodbye for this time. Thank you for your attention and see you next time.